The testing facility occupied an entire deck of Galactic University Station 12. Dr. Silenth had spent the previous night reconfiguring equipment, reinforcing structures, and consulting with engineers about safety margins. When Marcus arrived at the designated time, he found a space that looked more like an industrial complex than a medical laboratory. "We've borrowed equipment from the station's cargo handling systems," Dr. Silenth explained, gesturing at massive hydraulic lifts and reinforced platforms. "It was the only machinery rated for the forces we anticipate you might generate." A crowd had gathered in the observation gallery above. Students, professors, and station personnel all wanted to witness the testing of the human. Professor Zelthar stood among them, his tablet ready to record every detail. Commander Thrace was present as well, his security team standing by in case of equipment failure or unexpected incidents. Marcus wore simple athletic clothing, the kind humans used for exercise. The material was comfortable and allowed full range of motion. He'd eaten a substantial breakfast and felt ready for whatever challenges the day might bring. "We'll start with strength testing," Dr. Silenth announced. She led Marcus to a machine that resembled a massive press. "This device measures compression force. Place your hands on the grips and push as hard as you can. The hydraulic system will resist your force and record the measurement." Marcus positioned himself at the machine, gripping the handles. They felt cold and solid under his palms. "How hard should I push?" "Maximum effort," the doctor replied. "Don't hold back. The machine is rated for forces far beyond what we expect you to produce." Marcus nodded, took a breath, and pushed. The hydraulics resisted, but he could feel them giving way. Numbers on a display climbed steadily. He pushed harder, muscles tensing, and the numbers continued to rise. At what felt like his absolute limit, he held the force for 5 seconds, then released. The observation gallery erupted in shocked murmurs. Dr. Silenth stared at her instruments, then checked them again to ensure they were functioning correctly. 2,400 newtons, she said, her voice barely above a whisper. "That's nearly twice what I calculated as your theoretical maximum." "Is that good?" Marcus asked, flexing his hands. "Good. Marcus? You just generated enough force to lift approximately 240 kilograms straight up against standard gravity. That's the equivalent of lifting 3 Velnari simultaneously." Marcus considered this. Average adult humans can usually lift about their own body weight, give or take. Trained weightlifters can lift several times their body weight. I'm not particularly strong by human standards. The implications hung in the air. If an average human could generate such force, what could their athletes achieve? "Next test," Dr. Silenth said, moving to another station. "Grip strength. Squeeze this device as hard as you can." The grip meter was designed for species with grasping appendages. Marcus wrapped his hand around it and squeezed. The needle on the analog display swung past the maximum marking and hit the mechanical stop with a loud click. "The device only measures up to 800 newtons, the doctor said, examining the broken instrument. "You've exceeded its capacity. We'll need to requisition stronger equipment." They moved through a series of tests. Lifting strength, where Marcus raised weights that required industrial equipment to position properly. Pulling strength, where he hauled masses across the floor using rope and pulley systems. Impact force, where he struck a padded sensor with his fist hard enough to trigger safety alarms. "Your muscular system is remarkable," Dr. Silenth observed, reviewing the accumulated data. "But what's truly extraordinary is the coordination. You can generate enormous force while maintaining precise control. Watch this recording." She played back footage of Marcus lifting a 200-kilogram weight. His movements were smooth and controlled, without any shaking or instability that might indicate strain. His body moved as an integrated system, each muscle group contributing to the overall effort. "Most species experience coordination breakdown under maximum load," the doctor explained. The nervous system struggles to manage all the signals required for complex movements while also maintaining force production. You show no such limitation. Humans practice coordination from childhood, Marcus said. Walking, running, catching objects, manipulating tools. We're constantly training our neuromuscular systems. The next phase focused on endurance. A specialized treadmill, reinforced and rated for heavy industrial use, and had been installed in the testing area. Marcus stepped onto it while Dr. Silenth attached monitoring equipment to his body. We'll start at a walking pace and gradually increase speed, she explained. Continue as long as you're able. Tell us immediately if you feel any distress. The treadmill activated with a low hum. Marcus began walking, his pace relaxed and easy. The monitors showed his heart rate, respiratory rate, oxygen consumption, and core temperature. All values were within expected human ranges. After 5 minutes, Dr. Silenth increased the speed to a jog. Marcus adjusted his pace smoothly. His heart rate elevated, but his breathing remained controlled. 10 minutes passed. 20. 30. The doctor continued increasing the speed incrementally. Marcus moved from a jog to a run, and his feet hitting the treadmill's surface with rhythmic impacts that resonated through the deck plating. In the observation gallery, students watched in amazement. Most species couldn't maintain continuous movement for more than a few minutes. The human had been running for nearly an hour and showed no signs of stopping. His cardiovascular efficiency is extraordinary, Professor Zelthar observed, studying the telemetry data being broadcast to the gallery. His heart rate has plateaued at about 160 beats per minute. That's elevated, certainly, but stable. He's reached a steady state where oxygen intake matches oxygen consumption. Commander Thrace clicked thoughtfully. From a tactical perspective, this is significant. A human could pursue or flee from threats over vast distances. Now, sustained mobility is a tremendous advantage in any conflict scenario. Or in exploration, Professor Yenna added. Humans could traverse terrain on foot that other species would require vehicles to cross. 90 minutes into the test, Dr. Silenth finally stopped the treadmill. Marcus, that's sufficient data. You can rest now. Marcus slowed to a walk, then stepped off the treadmill. He was breathing heavily and had worked up significant perspiration, but he looked ready to continue if asked. How do you feel? The doctor inquired. Tired, but okay. I could probably keep going for a while longer. You just ran at an average pace of 12 kilometers per hour for 90 minutes, she said, disbelief coloring her voice. That's 18 kilometers of continuous movement. And you believe you could continue? Marathon runners cover 42 kilometers, Marcus reminded her. Ultra-marathon runners go even farther. 90 minutes is tough, but it's not my absolute limit. The doctor made extensive notes while Marcus drank water and allowed his body to recover. The human cooling system, she observed, was remarkably effective. Sweat evaporated from his skin, carrying away excess heat generated by intense muscular activity. Within 20 minutes, his vital signs had returned to baseline levels. The next test involves environmental tolerance, Dr. Silenth explained once Marcus had rested. We've prepared chambers with various atmospheric compositions, temperatures, and pressures. We need to understand what conditions humans can safely endure. The environmental chambers were specialized rooms where every variable could be controlled precisely. Marcus entered the first chamber, which was set to replicate Earth's atmosphere, but at elevated temperature. Over the next several hours, the tests continued. Temperature extremes revealed that humans could function in surprisingly hot or cold conditions, though comfort ranges were relatively narrow. Atmospheric tests showed that humans required specific oxygen levels, but could adapt to variations in pressure. Humidity tolerance was broad, and humans could operate in both dry and moisture-saturated environments. One test involved exposing Marcus to increased atmospheric pressure while monitoring his response. The Dr. Silenth gradually raised the pressure from standard to 1.5 atmospheres. How do you feel? She asked through the chamber's communication system. Fine, Marcus replied. Maybe slight pressure in my ears, but nothing painful. Your ears are responding to the pressure differential, the doctor explained. Can you equalize them? Marcus demonstrated the Valsalva maneuver, pinching his nose and gently blowing until his ears popped. Human divers do this all the time when they go underwater. Water pressure increases with depth, and we need to equalize to prevent damage to our eardrums. Fascinating. Your body has built-in mechanisms for pressure compensation. The environmental testing concluded with a spectrum analysis of Marcus's vision, and the results showed that humans could perceive light wavelengths from approximately 380 to 750 nanometers with peak sensitivity in the middle of that range. Your vision is optimized for your star's emission spectrum, Dr. Silinth noted. The sun you call Sol is a yellow dwarf star. Its light peaks in the wavelengths you perceive as yellow and green. Makes sense, Marcus said. We evolved under that light. Our eyes adapted to see what was useful for survival. As the testing day drew to a close, Professor Zelthar called a meeting in one of the station's conference rooms. Marcus joined him there, along with Dr. Silinth, Professor Yenna, Commander Thrace, and several other researchers who had been observing the tests. We need to discuss the implications of today's findings, Professor Zelthar began. Marcus, your performance exceeded our most optimistic projections in almost every category. This isn't just about you being from a high-gravity world. Humans possess a suite of adaptations that make you extraordinarily versatile and resilient. The question is why, Professor Yenna said, her crystalline form refracting the room's light into rainbow patterns. What about Earth's environment produced such comprehensive capabilities? Marcus thought about his homeworld. Earth is unpredictable. Our climate varies wildly by location and season. We have deserts, rainforests, tundra, mountains, oceans. Early humans had to adapt to all of it. The ones who could run long distances, who could handle temperature extremes, who could survive on diverse food sources, they were the ones who lived long enough to have children. Over millions of years, that pressure shaped us. Natural selection in a hostile environment, Dr. Silinth mused, but taken to an extreme we didn't think was possible. Commander Thrace raised a concern. We must address the security implications. I mean, no offense, Marcus, but your species represents a potential threat simply by existing. One human could physically overpower dozens of most species. If humans ever became hostile, the galaxy would be at a severe disadvantage. I understand your concern, Marcus replied carefully. But humans have been dealing with that same issue internally for our entire history. We've always had the capability to harm each other. What stopped us from constant warfare isn't lack of ability. It's the development of ethics, laws, and mutual cooperation. We learned that working together produces better outcomes than fighting. Have humans achieved universal peace? Professor Zelthar asked. No, Marcus admitted. We still have conflicts. We still make mistakes. But we're trying to be better. That's why we're excited about joining the galactic community. We hope you can teach us from your experiences, help us grow beyond our violent past. A humble perspective, Professor Yenna observed. You acknowledge your flaws while aspiring to improve. That speaks well of your species' character. The group discussed establishing protocols for human interaction with other species, guidelines for physical contact given the strength differential, recommendations for habitat design that could accommodate human needs, educational materials to help other species understand human biology and culture. We should also consider what humans can offer the galaxy, Dr. Silinth suggested. Your physical capabilities are formidable, but your problem-solving approaches might be equally valuable. Species that evolve in challenging environments often develop innovative thinking patterns. Marcus smiled. Humans are pretty good at finding solutions to impossible problems. We have a saying, necessity is the mother of invention. When we absolutely need something to work, we tend to figure it out one way or another. That adaptability will be invaluable, Professor Zelthar said. The galaxy faces many challenges. Climate change on various worlds, resource scarcity, unexplored territories. Human perspectives might provide breakthroughs we've been missing. As the meeting concluded, Professor Yenna approached Marcus with additional information about the archaeological expedition she had mentioned. I've received approval from the university to organize an expedition to the high-gravity world I mentioned, she said. The planet is designated G447 in our catalog, but the ruins suggest its inhabitants called it something that translates roughly to Forge World. I believe you could help us understand the civilization that once lived there. When would we leave? Marcus asked. In 3 months. We need time to assemble a team and prepare equipment. The journey will take approximately 6 weeks each direction, and we'll spend 4 weeks on the surface. It's a significant commitment. I'm interested, Marcus confirmed. And if there were other high-gravity species in the galaxy's past, I want to know about them. It would mean humans aren't completely alone in dealing with the challenges we've faced. Professor Yenna shimmered with pleasure. Excellent. I'll begin preparations immediately. Over the following weeks, Marcus's presence on the station became normalized. Other students grew accustomed to seeing the human in classes and common areas. He was careful to move gently around more fragile species, and his friendly demeanor helped ease initial fears. He participated in cultural exchange programs, sharing information about Earth and human civilization. He showed recordings of human cities, art, music, and technology. He explained concepts like democracy, individual rights, and the scientific method as humans understood them. In return, he learned about galactic civilization, the Velnari's philosophical traditions that emphasized harmony and balance, the Delphians' complex social structures that operated through chemical communication, the Aryans' unique perspective as beings without fixed form, the Kresh's hive-based societies where individual and collective consciousness blended seamlessly. One evening, Marcus was studying in the station's library when a group of students approached him. They represented 5 different species, all from his xenobiology class. Marcus, one of them began, a young Velnari named Thelris. We have a question. We've been thinking about humans and Earth, and we're curious about something. Sure, what do you want to know? Earth sounds terrifying, Thelris continued. High gravity, unstable geology, dangerous weather, predatory animals, diseases. Why would humans want to explore space? Why leave a world you're perfectly adapted for, even if it is harsh? Marcus set down his data tablet and considered the question. Because we're curious. Because we wonder what's beyond our sky. Because staying in one place, even a place we're adapted for, means we'll never know what else is out there. He gestured at the library around them, at the thousands of texts from hundreds of species. Look at all this knowledge, all these different perspectives. Humans would never have discovered any of it if we'd stayed on Earth. But you're risking so much, another student said, a tentaculin named Quira. Every human who comes to space is vulnerable in ways you never were on Earth. The gravity is too low. The environment is artificial. You're far from medical facilities that understand your biology. True, Marcus acknowledged. But humans have always been willing to risk safety for discovery. Our ancestors crossed oceans without knowing what was on the other side. They climbed mountains because they were there. They pushed into hostile environments driven by curiosity and the desire to explore. Coming to space is just the latest chapter in that story. Aren't you afraid? Thelris asked. Marcus thought about it honestly. Sometimes, yeah. Being this far from home is scary. Knowing that I'm surrounded by beings who don't fully understand me and who I don't fully understand, that's uncomfortable. But the excitement outweighs the fear. Every day here I learn something new. Every conversation gives me a different perspective. That's worth the risk. The students seemed to appreciate his honesty. They talked for another hour, comparing their species' approaches to exploration and discovery. Marcus learned that most galactic species expanded into space gradually, driven by necessity or overpopulation rather than pure curiosity. The human approach, throwing themselves into the unknown for the sake of knowledge itself, was unusual. "Your species is strange," Quira finally said, though her tone was affectionate rather than critical. "But I think the galaxy needs strange. We've been doing things the same way for a long time. Maybe humans will shake things up in good ways." As the months passed, Marcus prepared for the expedition to Forge World. He studied the available data on the planet, which was limited. In the world orbited a orange dwarf star and had gravity approximately 1.1 standard units, slightly higher than Earth. The atmosphere was breathable but thin. Temperature ranges were extreme. The ruins dated back at least 50,000 years, but no one knew what had happened to the civilization that built them. Professor Yenna assembled a team of 12 researchers from various disciplines: archaeologists, geologists, biologists, linguists, all curious about the mysterious high-gravity world. Marcus would be the only human, but the team included representatives from 6 other species. The expedition ship, named Scholarly Pursuit, was a research vessel designed for extended missions. It had facilities for analysis and study, comfortable accommodations for the crew, and enough supplies for a 4-month journey. And on the day of departure, Marcus stood in the docking bay, a pack with his personal belongings slung over his shoulder. Professor Zelthar had come to see him off. "You've changed things here, Marcus Webb," the professor said. "Before you arrived, we thought we understood the limits of biology, the constraints of evolution. You've shown us how wrong we were." "I just showed up and existed," Marcus replied. "Humans didn't set out to break anyone's theories." "Precisely. You didn't need to try to be revolutionary. Your very existence challenged our assumptions." The professor extended a hand in the human gesture of respect. "Learn everything you can out there, and come back safely to share it with us." They shook hands, and Marcus boarded the ship. The crew welcomed him aboard, showing him to his quarters and the common areas. And within an hour, the Scholarly Pursuit undocked from the station and began its journey toward the outer reaches of explored space. The voyage was long but productive. Marcus spent his time learning from the other researchers, studying their methods and perspectives. He taught them about human approaches to archaeology and planetary science. He shared stories about Earth's history, about the ancient civilizations that rose and fell on his homeworld. 6 weeks after departure, they arrived at G447, the Forge World. The planet hung in space like a dusty red marble, its surface marked by ancient mountain ranges and dry seas. Scanners detected the ruins immediately, vast cities spread across 3 continents. The ship entered orbit, and the team prepared for descent. Marcus felt his heart rate increase with anticipation, that they were about to explore the remains of a civilization that might have been similar to humanity, a species that had thrived under crushing gravity and then mysteriously vanished. As the landing craft descended through the thin atmosphere, Marcus looked out at the alien landscape below. Rocky plains stretched to distant horizons. Massive structures, weathered by time but still standing, dotted the surface. This was a world that demanded strength to survive, just like Earth. The craft touched down near the largest complex of ruins. The team disembarked carefully, testing the environment. The gravity pulled at them, heavier than the station but manageable for most species with assistance from their exosuits. Marcus stepped onto the surface without assistance, feeling the weight settle into his bones. 1.1 standard gravity, slightly more than Earth, enough to notice but entirely bearable. "This feels right," he said softly, looking around at the ancient city. "This feels like a place where beings like humans could have lived." Professor Yenna's crystalline form glittered in the orange sunlight. "Then let's find out if you're correct. Let's discover who built this place and why they're no longer here." The team spread out, beginning their survey of the ruins. Marcus walked among buildings constructed from stone blocks that must have weighed tons. He saw infrastructure designed for beings who could handle heavy loads. He found what might have been exercise facilities or training grounds, places where a strong species might have tested themselves. As the sun set on Forge World, painting the sky in shades of amber and rust, Marcus stood atop an ancient wall and looked out across the dead city. Somewhere in this galaxy, perhaps long ago, another species had looked up at the stars and wondered what was out there. They had built a civilization, reached for greatness, and then vanished, leaving only questions behind. But humans were here now. Humans had proven that high-gravity species could not only survive but thrive, could build civilizations and reach for the stars despite the weight pressing down on them. Whatever had happened to the builders of Forge World, humanity would learn from it, would carry their legacy forward. The universe was vast and full of mysteries. But as Marcus stood there, under the light of an alien sun, on a world that felt almost like home, he knew that humanity had earned its place among the stars. Not through force or conquest, but through persistence, adaptability, and the sheer stubborn refusal to accept that anything was truly impossible. Professor Zelthar had once believed that no species could endure one standard gravity unit. Marcus had proven him wrong simply by existing, by standing when theory said he should fall. And now, standing on Forge World, Marcus represented something greater than just one human. He represented the potential of all beings who faced impossible odds and chose to overcome them anyway. He represented the truth that the universe's laws were more flexible than anyone had imagined, that life could find a way even in the harshest conditions. As stars began appearing in the darkening sky, Marcus smiled. The galaxy was full of wonders waiting to be discovered, mysteries waiting to be solved, and connections waiting to be made. The humans had only just begun their journey, but already they were changing the galaxy's understanding of what was possible. And that, Marcus thought, was exactly what humanity did best, proving that impossible was just another word for challenge accepted.